Hi, in this video we are just going to see about the basic differentiation and its related problems. Let's go to watch. Differentiation means rate of change of one quantity with respect to other. It determines the tangent to the curve and it represented by d by dx or y1 or y dash, and here we representing x as an independent variable and y as dependent variable. Before going to start, here I'm just giving some examples of tangent line, and the first one is the tangent line touching with the circle, and the second curve is the tangent line is touching with one point, and the third one is the tangent line is touching in intersecting in 2 points. Here the second line is represented as the slope of the tangent line. Here the horizontal line is represented as del x and the vertical line is represented as del y. So the formula for slope for the tangent line is nothing but del y divided by del x. So next we're just going to see about the real life applications of differentiation. The differentiations are used in a wide variety of disciplines from biology, economics, physics, chemistry and engineering, and it describes exponential growth and decay and the change in investment return over time. More complicated differential equations can be used to model the relationship between predators and prey. In medicine, for modeling cancer growth or the spread of the disease, the differentiation is used. The engineering for describing the movement of electricity, we using the differentiation concept. Also in chemistry for modeling chemical reactions, and in economics to find optimum investment strategies, and in physics to describe the motion of waves, pendulums or chaotic systems, we are using the differentiation concept. So now the general differentiation equations of the form d by dx of y is nothing but g of x, where y is represented f of x here. This type of equation is known as a differential equations, and we have two type of differential equations. One is ordinary differential equation and another one is partial differential equation. I'm here giving some three different equations to identify whether it is a differential equation or not. So the above three equations involving dependent and independent variables. Here dependent variables is x and independent variables y. But here the derivative d by dx is not involving in the given three equations. So the given three equations is not a differential equation. But the x into d by dx of y plus y is equal to 0 is involving derivative of the dependent variable with respect to independent variable. So these type of equations is known as a differential equation. So in this video we're just going to see the ordinary differential equation, and shortly we noted as ODE, and we will see later as a PDE of partial differential equation. So definition of ordinary differential equation is nothing but a differential equations involving derivatives of the dependent variable with respect to only one independent variable is known as ordinary differential equation. For example, here I'm giving one example that x into d by dx of y plus y equal to 0. Here the dependent variable is y and the independent variable is x, and the only one independent variable x is only exists. So these type of equation is known as the ordinary differential equation. So I'm just given a definition of partial differential equation only. So no, I'm not given a problem because it is very big chapter. So I skipped in this video for a PD. So yeah, let's see the PD definition. The differential equations involving derivatives with respect to more than one independent variable called partial differential equations. So for example, dou by dou t of y is equal to dou squared by dou x squared of y. Here y is an dependent variable, but we have here t and x as a two independent variable. So in definition, more than one independent variable is known as partial differential equations denoted. So this type of equation is known as partial differential equation. So let's see the order of differential equation. The definition of order of the differential equation is the order of the highest derivative present in the equation. I'm giving first and second order uh, differential equations. The first equation is x into d by dx of y plus y is equal to 0. Here d by dx of y is nothing but the y is differentiated with respect to x on one time only. So this type of equation is known as first order differential equation. If the given equation is differentiated for two times, then the equation becomes d squared by dx squared into y term. So this type of equation is known as second order differential equation. Next we see the degree of differential equation. The degree of differential equation is represented by the power of the highest order derivative in the given differential equation, but the differential equation must be a polynomial in derivatives for the degree to be defined. So here I have given some examples whether we can find the degree of the differential equation or not. In first equation, let's see the first equation. Here I am giving d cube by dy by dx cube of y plus d squared y by dx squared is equal to 5. The highest order degree here is 3, that is d cube by, this equation is differentiated for 3 times. So d cube by dy divided by dx cube is the higher order derivative. On the power of in the power of the higher order derivative is 3. So in this equation, the degree of the differential equation is 3. I have equation d squared y by dx squared plus dy by dx the whole power 3 plus sine of d squared y by dx squared is equal to 9. Here the higher order is d squared y by dx squared and the power is 1. So we can write it as the degree is 1 or not. Definitely not, because here we have a sine form, that is a trigonometric form. So we know the formula for sine x, cos x, etc. When we replace sine x as d squared y by dx squared, so we can get the power is high, that is d squared y by dx squared minus d squared y by dx squared whole cube plus etc and so on. So we cannot determine the highest degree of the given equation. So these type of equation we cannot determine the degree of the differential equation. Similar for the next equation for cos function. Next we see the general and particular solution of differential equation. So the general solution of the differential equation, which contains arbitrary constant, that is a, b, c, etc. Then this type of solution is known as primitive solution or a general solution of the differential equation. The next one is particular solution. The solution obtained from the general solution by giving particular values to the arbitrary constants is known as pi. So the particular solution is shortly denoted as pi, and for pi we have more different types to find out the value. I have given example for general solution. Here you have to remove the arbitrary constant a and b, so that we can get the solution as d squared by dx squared of y plus y equal to 0. That only we have to verify the given problem. So here I'm going to take a function y equal to a cos x plus b sin x. Here the arbitrary constants a and b are in multiple form. So in differentiation we cannot arbitrary constant directly. So first we are going to differentiate the value once. So by differentiating once, we get dy by dx is equal to By differentiating cos x, we have minus sin x. So the first term becomes minus a sin x, and the second term by differentiating sin x we get cos x. So plus b cos x. Substituting the value of d squared by dx squared of y and the function y equal to e cos x plus b sin x in the given equation d squared y by dx squared plus y. So we have in LHS side minus a cos x minus b sin x plus a cos x plus b sin x. It equals to the right hand side, that is the value of 0. So therefore the given function is a solution of the given differential equation. Next we see the formation of a differential equation when general solution is given. For example, for form the differential equation representing the family of the curve y equal to mx, where m is arbitrary constant. Here the equation y equal to mx is given. So here the arbitrary constant is m. So here we have to differentiate the given equation to eliminate the arbitrary constant m. So by differentiating y equal to mx, we have dy by dx is equal to by differentiating mx, x is changes as 1. So we get d by dx of y equal to is nothing but m. By replacing m as d by dx of y, we get the value of y equal to x into d by dx of y. By replacing all the values, we get the equation finally as x into d by dx of y minus y equal to 0. So next one, we see the another one example. Form the differential equation representing the family of the curve y equal to a sine of x plus b, where a and b are arbitrary constant. In first example, we have only one arbitrary constant, so we have differentiated only one time. But in this problem, we have two arbitrary constants a and b, so we have to differentiate two times, then only we can eliminate the arbitrary constant in the given problem. So by differentiating first time, we get d by dx of y equal to, here a is in multiple form, so a it is as well as a, and by differentiating sine of x plus b as becomes cos of x plus b, and differentiating once again we get the value of d squared by dx squared of y. So the value of d squared by dx squared is minus a into sine of x plus b. Substituting all the values in equation 1. Okay, the next topic is method of solving first order first degree equations. We hope that we all are familiar in first order and first degree equations in the previous sessions. So let's go to the definition shortly. Differential equations with the variable separable first order first degree differential equations of the form d by dx of y is equal to capital F of x comma y. Here capital F is defined as function. It may be any type of function, that is algebraic, trigonometric, and like that the any type of function we can have. So for problem, so we go for a problem number 1. Find the general solution of the differential equation d by dx of y is equal to x plus 1 by 2 minus 5. Here capital F of x comma y is given that x plus 1 by 2 minus 5. This type of function is known as the, here x and y only exist, so this type of function is known as algebraic function. So we can solve this problem directly. So by the problem we have d by dx of y is equal to x plus 1 by 2 minus. I take it as equation number 1. Before going to find out the general solution, we are going to separate the equations. So I am separating y terms on left side and I am separating x terms on right side. So here the operators is y and x. So and after that I am going to eliminate the derivatives also and eliminating the constant term also. So for that I am taking an integrate concept, that only we can eliminate the constant term. So I'm integrating a left side on with respect to y, and right side with respect to x. So here we have two terms, 2 and minus 5. So I am going to integrate 2 separately and as well as y separately. So by integrating 2 we get 2y, and here minus as well as right as minus, and by integrating y we have a basic formula for integral concept, that is integral x power n into dx is equal to x power n plus 1 by n plus 1. So instead of x we have here y, and the power of y is here nothing but 1, that is y is hidden here, so n is 1. So by replacing the values x as y and n as 1, we get y power 1 plus 1 by 1 plus 1, that is y squared by 2. So we have got a value of value y 2y minus y squared by 2 is left side. On repeating the same formula for the right side, we get x squared by 2 plus x, plus additionally we are adding a constant c. Why we are adding constant c here means then only we can get the um, uh, correct value. That means in integration we cannot find out the exact value, so that's why we are adding a constant c. So we'll see the next problem. In the bank, principal increases continuously at the rate of 5% per year. In how many years rupees 1000 double itself? Here the principal amount capital P is given, that is 1000, and the rate of change is 5%. So here what is given, that the principal increases continuously at the rate of 5%. So here the rate of changes exists, so we have to clearly we can get an idea about the differentiation. So here asking the question is the year, that is we are going to find out the year t. So that's why first I am going to take a given terms, that is dp by dt, that is the principal of increases continuously at the rate of t. So here the rate is 5%, is a 5 by 100, you can write it as into the principal amount is capital P, which is equal to dp by dt is equal to by eliminating 5 by 100 we get p by 20, the final term. So after that I have taken capital P is equal to 1000 at any time, because the exact year is not given, so but initial time the P is given, that is time t at time t 0 the P is 1000. So next we are going to separate the dp by dt is equal to capital B by 20. So I'm going to separate the p terms on one side and t terms on other side. So the right side capital P is down to the will come down to the left side, and dt is going to right side on the top. So previous slide we have on left side is dp by p. So by integrating left side we get log p, because the integral of 1 by x into dx is nothing but log x. So instead of x we have p, so we have written it as log p on left side. On right side we have a term 1 by 20 is there. So by integrating a constant term with respect to t we get t by 20, plus additionally we are adding the constant term c, because in integration we cannot find out the exact value. So finally we got log p is equal to t by 20 plus c. So I am going to eliminate the long term. For that um, I'm inserting a e exponential term on both sides. So on left side e power we get e power log e log p is equal to e, on right side e power t by 20 plus c. See here e and log are reciprocal, so on left side the e and log are eliminator. So finally we get p is equal to e power t by 20 plus c. So after that separating the term on right side e power t by 20 into e power c we can separate. So c is always constant term. On the power of any term c, that are also constant. So e power c e value is always constant, and e power c also constant. So I write it as capital C. So finally we got capital P is equal to c e power t by 20. Take it as equation number 2. And in given problem, the p equal to 1000 is given at any time t equal to 0. So I'm going to substitute the values capital P is equal to 0 and the time equal to 0 in equation 2. So by replacing the value capital P is equal to 0, on left side we get 1000 is equal to c into e power, I'm applying t as 0. So 0 by any term is 0. So e power 0 we get. So e power 0 value is 1. So the value of capital C will be 1000. So again the finally the equation 2 will become capital P is equal to 1000 into e power t by 20. Next topic is homogeneous differential equation. A differential equation, the form d by dx of I is equal to capital F of x comma y is said to be homogeneous if capital F of x comma y is a homogeneous function of degree 0. If I get a homogeneous function degree is 0, then the given equation is said to be a homogeneous differential equation. For example, the differential equation given as dy by dx is equal to x plus 2y by x minus y. Here capital F of x comma y is x plus 2y by x minus 2y. So to find out the degree of the given equation, you have to replace x as lambda x and y as lambda y. So I'm applying x as lambda x and y as lambda y in the given problem. So on the right side we get lambda x plus 2 lambda y by lambda x minus lambda y. On separating the terms lambda on numerator and denominator, we get lambda 1 by lambda, that is lambda power taking denominator term to numerator. So lambda power 1 minus 1 we get. So lambda power 0. So the power of the lambda is 0. So in the given problem the lambda value is 0, that is degree is 0. Hence the given equation is homogeneous equation. Let's see the final topic, linear differential equation. A differential equation is of the form dy by dx plus capital Py is equal to capital Q. So here I'm going to separate P term and Q term only. Uh, here the term will be like that. For example, dy by dx of y plus y cot x is equal to 2x plus x squared into cot x, where x is not equal to 0 is the given condition. So by comparing the comparing the sum to the general term, we get the second term is y into cot x, that is instead of p we have a cot x, so I am writing p as cot x. On the right side we get q, so the whole term, the remaining whole terms are same. So suppose we have x as y, we cannot write this q, so here the whole term will is in x, so I am taking q as 2x plus x squared into cot x. Hope you all learned something with this. Thank you.